Good afternoon, everyone, and welcome to today's Public Health Ontario Rounds presentation on Listeria in food processing environments. My name is Jenny Kim, and I'm the physician lead of environmental and occupational health at Public Health Ontario, and I have the sincere pleasure of moderating today's session. Before we begin, actually, I will mention a few housekeeping items. First, the chat pod has been disabled to limit any distractions during the presentation. If you have any questions for the speaker today, please instead use the Q&A pod if you have any to type in your questions during the session. A discussion and question period will follow the presentation. Our speaker and I will make every effort to address as many questions as possible. And if at any point during this session you experience technical issues, please email capacitybuilding@oahpp.ca. And I believe that email address will pop up in the chat box momentarily. And I would like to state that as a moderator of this session, for this session specifically, I don't have any conflicts of interest to disclose. I am, however, a shareholder in my spouse's design company. And with that, it is now my pleasure to introduce the speaker for today's session, Troy Jenner. Troy Jenner has a long history in food safety that began with Campbell Soup in their quality assurance department. And from there, he went to the Ontario Ministry of Agriculture, Food and Rural Affairs, or OMAFRA, where he was an architect of the Hazard Analysis and Critical Control Points, or HACCP, Advantage, which is an outcome-based HACCP food safety program for provincial food safety processors. For the last decade, he has been the manager of the Food Safety Science Unit, overseeing the Ontario Ministry of Agriculture, Food and Rural Affairs sampling and testing program, baseline research projects, and providing technical support to the inspectorate. So with that, I'd love to welcome Troy and for him to take it away. Thanks, Troy.
Thanks very much, Jinhee. Happy to be here. Excited to talk to you all. Haven't really done one like this before, but always good to talk about pathogens and Listeria and things like this. And I hope you find it useful and we can have a good discussion at the end. To just get started, let me get my mouse here. By the end of this session, hopefully you'll be able to describe the dangers of Listeria and what it is and kind of what leads to it, the challenges of kind of controlling it in any food processing environment, whether it might be one that we regulate here at OMAFRA or whether it's one that you would see in public health units, in retail stores, in butcher shops, and all sorts of things. We'll kind of talk about the roles of an environmental monitoring program and how important it is and helpful it can be to mitigating the risks of Listeria. And linked to that, we'll also talk about root cause analysis a little bit and how we use it to identify Listeria issues and hopefully eliminate them. And we'll kind of then summarize the strategies for managing Listeria in food production environments. I am coming from a perspective of a lot of the facilities that we regulate here at OMAFRA, although I do think that they're applicable to a wide variety of different retail and different food processing operations, all kind of along the value chain. So I think it's very applicable. As part of that kind of 3 and 4 too, I'm also going to talk about some of the experiences and what we found in a baseline study that we have done a few years ago here at OMAFRA that kind of led to our current environmental monitoring program and some of the information and what it told us and what you can take from that. I think it's pretty interesting. So let's start about what it is. So you probably heard Listeria before, and a lot of people like to say the term Listeria hysteria because it does cause quite significant concern. Listeria collectively is talking about a whole group of species of bacteria. Only a few of them, very small number of them, are actually pathogenistic. One in particular, Listeria monocytogenes, is of real import because it does cause significant disease and has caused some pretty serious outbreaks. Monocytogenes will cause a disease called listeriosis, unsurprisingly. And it, when left unmitigated or untreated, can really create bigger and more grave conditions that can lead to pretty severe outcomes, including death. You know, when you get this type of foodborne illness, you're going to kind of get a lot of the typical type symptoms that you would associate with foodborne illness. You know, and some flu-like symptoms. You could be vomiting, fever, headache, all those sorts of things. Difficult to differentiate some of those symptoms from other foodborne pathogen type diseases. And for a large percentage of the population, you would experience those and probably recover, not unlike you would other illnesses. In more severe cases, especially amongst the immunocompromised and pregnant women, there are definite much bigger risks. Listeria really preys on the immunocompromised people that can't fight illnesses very well. And you know, if you get pregnant women getting listeriosis, results in a very high rate of stillbirth. So it's very dangerous for those as well. And that's why you'll quite commonly see for those any you know, pregnant or formerly pregnant women or couples in the audience, you know, you probably have heard your doctor say you might want to not eat things like RT deli meats or other products that would be generally a bigger risk for listeriosis. That's where that comes from. You've probably, you know, here's a list of kind of some outbreaks that we've seen. You know, the very bottom one on that page in 2008 at Maple Leaf is kind of still a bit of a hallmark moment for food safety in Canada. It results in a lot of changes, a lot of differences. You know, prior to 2008, you know, we weren't doing a ton of inspection in some of these types of facilities, and that changed that a lot, and upped it, and we have more inspection presence and more monitoring programs. But you know, that's pretty long in the tooth now. It's, you know, over 15 years ago, but since then we still had a fair number of outbreaks. Just last year in June, there was 16 states, pretty wide leafy greens outbreak, and you know, caused a number of hospitalizations. There was one in last spring linked to deli meat and cheese. Again, large number of hospitalizations and a death. And then in just over a year ago, there was one linked to ice cream. So you can see a whole variety of foods, doesn't really care. Lots of hospitalizations, some deaths. The Maple Leaf one was definitely a very dangerous and pathogenic strain. It caused a really high death rate. I mean, much more than 16%, as you can see. As with many outbreaks, you know, we expect that the actual number of cases probably far outweigh what we're actually getting reported. A lot of people do kind of experience, again, like I said before, those typical foodborne illness symptoms, sick for, you know, 2 to 4 days, kind of recover. And a lot of those times, those things aren't actually get reported. So we expect those numbers are probably bigger in many of those outbreaks. You know, Listeria is a ubiquitous organism. It's kind of everywhere all the time. If you were to go outside and pick up a handful of dirt, there's a really good chance you're going to have Listeria in it, maybe even Listeria monocytogenes. We live in Canada. Obviously, we get lots of freezing and thawing. It doesn't seem to blink an eyelash. You know, it can really grow in a wide variety of environments. And since it's kind of everywhere, it really can be introduced through a lot of raw materials, including food, raw foods, including packaging materials, including people. And since it can grow in cool, refrigerated conditions, unlike most other pathogenic bacteria, it is, you know, makes it more of a problem. It also can be very resistant to freezing, drying, high levels of salt or nitrate or acid. You know, and those last few, the drying, salt, nitrate, and acid, those are actually hurdles we use to limit pathogenic bacteria. So the fact that they're resistant to these things also complicates things and makes those steps really, really important. Most pathogenic bacteria can, you know, some of them can survive cold temperatures, you know, 4-degree, you know, refrigerated temperatures. Listeria can actually grow, can actually proliferate and become a bigger problem, which is important. Listeria also is really, really adept at forming biofilms. And biofilms is something that we struggle with, I think, as a regulator in our inspectors and then the operators to actually control. Biofilms are really invisible, sticky layers of bacteria, sugars, proteins, other substances that kind of form and adhere together, and they basically shield themselves from, you know, they stick there and they're very hard to get rid of. They can shield it from high pressure water, things like that. And, you know, every place that produces food probably has, should have well-developed sanitation procedures in place for cleaning surfaces. A biofilm, if it exists after you've done sanitation, that's been resistant to those sanitation processes. So any further steps you're going to have to do will have to be greater. And, you're going to hear me talk a lot about follow-up and response to positives and things like that. And we have issues with plants that have positive Listeria, and the inspectors will tell us that, well, they've cleaned and sanitized afterward. One of the first things I'll ask is, I'm like, well, what did they do different? I mean, they ostensibly had cleaned and sanitized before the initial positive, and now we have it. So we should be doing more than we were doing before. And a lot of times that more is really to eliminate those biofilms. We have had instances in some of our facilities where we also have a finished product testing program. And we've had instances where we have found Listeria either in a product or maybe in one of our environmental monitoring programs. Had the plant clean, follow up, eliminate those, try and eliminate the source of those, and then kind of followed up again and had negative tests. And so we're thinking, oh, great, we've eliminated. But then a year or even 2 years later, we've picked up another positive, and then we've been able to, compare the whole genome sequencing of those Listeria, and in fact, they are the same or very, very closely related, which tells us that in the interim time, we never really ultimately got rid of it, even though we got negative tests. It was sitting there lurking somewhere. We didn't know where it was and couldn't get rid of. And, we've had to do it again. So it really highlights persistence the Listeria has, and really how important it is to really properly deal with it. I've kind of talked a little bit about this. So when you introduce Listeria in a plant, it can kind of get everywhere, and it doesn't really need a lot of space. Really likes tight spaces where it can form those biofilms, and loves water, helps it stay hydrated. Then when you have those places, and they don't need to be food contact surfaces, you get a lot of transfer, and you can get transfer from onto ready-to-eat products or surfaces that ready-to-eat products would touch. So you could kind of get indirect transfer. And when we see results in our finished product testing program where we get Listeria mono positives and we can enumerate those, we see the numbers, and it's more common that when we look at that data, we see numbers that suggest that it's been a contamination event, like a post kind of kill step contamination event, rather than kind of what I talked about before about it just being introduced into the raw materials and not actually eliminated through proper hurdles. When we talk about RTE, ready-to-eat foods, of course, when the consumer isn't actually doing anything else to control that risk, the risk of those things really goes up quite significantly. So all those leafy greens, things you put in your salad, ready-to-eat deli meats, stuff like that doesn't receive those steps by the consumer, we really want to try and ensure are free from Listeria. Okay, so which leads me into environmental monitoring programs. So an environmental monitoring program, and from now on, I'll just call them EMPs. They are, a program that really tests the surfaces for microbial contamination. So we're not actually testing food. And they're really helpful to identify locations in a facility that could harbor these pathogens and how they might move throughout the plant. And when you take some of these testing programs and you kind of compare results over time, you can really start to illustrate that, especially in facilities that are struggling with some sort of problems. Positive results enable operators kind of seek and destroy harborage areas and prevent further cross-contamination. And it's really meant to be a really proactive approach to ensuring good, strong sanitation GMPs and helping to prevent contamination. I put a couple points in here very specifically because when we rolled out this program to our freestanding meat plants and the operators that make a lot of these RT programs, there was a lot of concern, reticence, even some fear about what it would mean. And, I spent some time, we did a webinar, and I really talked about how the identification of a Listeria positive in a monitoring program is really a really good thing. You'd much rather hear than in a finished product. And plus, it allows them to kind of follow up and have some real clear idea of what could be happening and some actual starting points to figure out how to solve it. And, so once I kind of changed a little bit of the thinking around it being kind of bad news, that it's actually good news. We saw a lot more uptake, and we have seen a pretty big improvement in our A&P numbers, both since the program started, but also in our finished product program since we started the A&P, and I'll talk a little bit about that very shortly here. So we do use now E&Ps as a routine monitoring program. So most of our plants are kind of getting swabbed somewhere between every 2 weeks to every 6 weeks, depending on a variety of factors, risk factors, things like how much they make and volume, size, type of products they produce, the history of their compliance and past test results and fractions, things like that. And it also allows us to get a better sense of the sanitary conditions of the facility as a whole, rather than kind of just from one finished product. And so we have a lot of plants that make a wide variety of products, and it's not feasible nor actually very cost effective for us to kind of test every single product or every single type of product that they might make, especially if they're making things in relatively small batches. So the E&Ps are really helpful, especially in these types of facilities. When you do an E&P, you're going to test kind of both food contact surfaces, or you'll see FCS, or non-food contact surfaces, or NFCS, and we represent those swab locations into 4 zones. And on this next slide here, I'll show you what those zones look like. We have the first one is just all the food contact surfaces. So that's zone 1. That's the high risk. That is where traditionally and predominantly we probably focus a lot of our swabbing, but not a crazy amount more. Zone 2 is really important too. I'll explain why. But zone 1 is going to be your things like your slicers, peelers, fillers, basically any piece of equipment or any knife that actually is touching the food and processing in some way or putting in a package. Obviously, those surfaces need to be clean, and more importantly, they need to be cleanable. And we've seen instances where that might not even be the case. Zone 2 is our kind of non-product contact surfaces, but these are the surfaces that are like immediately adjacent or next to. So there'll be parts of equipment that are kind of, the exterior of, guards of, underneath, right around, part of the undersides of bins, things like that, where, you don't expect the food to touch, but you do expect the people or other parts of equipment to touch, then could touch the food. So it's kind of a moderate risk. Zone 3 would be kind of the other areas with any finished product room or any finished product processing area, that you wouldn't necessarily associate with the food processing itself, typically. So you can see some examples here, forklifts, wheels, trains, phones, those sorts of things. Zone 4 would be areas that are in a facility that are completely outside of the RT production area. Typically will be, more communal staff areas, cafeteria, locker rooms, hallways. We spend very little time, if any, testing here, and I'll talk about the breakdown about why. And that's because, you're not focusing sanitation there, and you really should have strong GMP and personnel measures between those areas to prevent contamination. And that'll be one of the things that will really help control it. So you can see here, one thing in this kind of table, you can kind of see how we design most of our swabbing. Now, we design a swabbing program for a wide variety of plants that make a wide variety of products. We have environmental monitoring programs not only in our freestanding meat plants, but we also in our dairy plants, also in our plants to do, foods of plant origin, bag salads, things like that. We have a new fish program that started last year. We have a swabbing program there. So we're doing environmental swabbing in basically everywhere we inspect. There are some differences. Here is the kind of how we break down our swabbing by zone. Typically, we're taking 10 swabs at each visit. So it would be half in zone 1, 3 in zone 2, 2 in zone 3, and none in zone 4. The only time we would swab in zone 4 is if we're kind of following up to something that has led us down a path of investigation that we want to eliminate. It's, we do want to focus on zone 1. It does have the highest food safety risks, so that's why we're there. But one thing that's really, really important, and we are always constantly urging facilities to implement their own swabbing programs or their own testing program. They're not really that expensive. They're not nothing, but they're, I do refer to it as cheap insurance. But every facility is so different in age, different in size, different in design, different in kind of how product might flow through the plant. And really all those things, if we had the time and effort and the ability, we would probably design more specific EMPs that are applicable to those facilities. We don't really have that ability. But if a plant were to do one, those things are really important. And you might want to do all zone 1 and 2 or more of a blend. There's lots of different ways. And you can play with those numbers too, depending on your results, if you so chose. When we do a finished product testing program, we're looking for Listeria monocytogenes. And it was in this slide, but I didn't go over it. When we're doing swabbing, we're actually not speciating at all. So we're testing all positives for all Listeria, even if it's not pathogenic, because if they're positive for Listeria, then that means the conditions definitely exist for L mono to proliferate, and we want to eliminate those conditions. And so we use those as guidance. We shouldn't have any Listeria. So also focusing on L species provides us as a regulator a little bit of ability to collect more information with not a ton of the risk associated with finding the pathogen. Now, if we get a lot of positives, L species on a particular, especially a food contact surfaces, or we have repeat positives with a particular plant, we have a whole bunch of protocols that we go through, and we will get to testing for L mono and for testing for product. And so that happens following a process and in discussion with the inspection team and with the rest of the support staff here at OMAFRA. Okay, so root cause analysis. You heard me refer to this. Root cause analysis, super important. This is not a concept that's particularly new, and it's certainly not a concept that's really applicable to just food safety. Root cause analysis is an approach that is applied in a wide variety of different industries. And essentially is that when you have a system and something has happened that has led to a bad result, you want to uncover what caused that result. And this is what a root cause is. And really, you're trying to find the fundamental reasons behind the contamination event that led to a positive swab or led to a positive product. You want to find out what that is and eliminate it. Easiest way to do this, and you've probably heard this before, is kind of the 5 whys, or as the case may be, 6 whys, 7 whys, 8 whys, doesn't really matter. But the idea is that you just keep asking, why did this happen? Why did that happen? And, if you're going to review those things that were in that poll questions, and you found something that, say we were cleaning a piece of equipment and you had to make a mixture of a sanitation chemical to apply, and you check the chemical, check how strong it was. It's not strong enough. Well, why did you have the positive? Well, the chemical wasn't strong enough. Our solution wasn't strong enough as what we want it to be. Well, why wasn't it strong enough? Well, it wasn't mixed properly. Well, why wasn't it mixed properly? Well, the pump that pumps in the chemical was broken. They did it by hand. Well, why was the pump broken? Well, the pump had never gotten any preventive maintenance. Well, why didn't it get any? And so you do this over and over and over again until you kind of get to something that you can actually do to fix it. And you do this for a wide variety of areas. Root cause analysis are not set in stone, true blue magic bullets. You can see we use words a lot like potential. We want to try the potential causes. It's going to be very difficult to know for sure whether you've identified it. So you fix the causes you think it is, and then you retest and you readdress anything new that might come up. Again, I can't stress enough, understanding every plant situation is unique. So it's really, you have to consider and examine the plant specific processes to help find the root cause. I've had people ask me kind of remotely, well, could you do a root cause in this plant? No, not really. I can't, not with, and really only lots of people can do root causes that are really good food safety practitioners, inspectors for sure. But empowering operators and staff that work in those facilities do that is even better, because they're going to know the nuances of those operations better and probably do a better job of answering those questions. You can see kind of the different areas that are typically types of the causes. Sanitation is first and foremost, and I'll touch on that before, but product flow, storage and handling, super important. Equipment and maintenance, super important. We've seen lots of instances where we've done a whole bunch of sanitation. We're super confident in the level of sanitation that's being applied, both in the chemical and how it's being conducted, how equipment might be dismantled for cleaning, and then still had positives, and then ultimately come to the conclusion that, you know, this particular equipment can't be cleaned to remove those biofilms in such a way that we could guarantee Listeria negatives. And so there has been some instances where we've seen equipment being replaced for exactly that. So anytime any of your, you know, operators you might be inspecting or asking about equipment, anytime they're purchasing equipment, sanitary design and the ability to clean it should be paramount. Okay. Once you kind of figure out what you think the root cause analysis says is the cause, you got to do corrective actions, right? And I've touched on this briefly before, but any corrective action or any response to a Listeria positive, either in finished product or in a swabbing program, needs to be better and more than what you did before. And again, it's going to be a lot of changes. Sanitation, you might upgrade your facility, better staff training. You do some follow-up swabbing, see if you get the same results. If you don't get the same results, great. Then you do some swabbing a little bit further after that. Typically, what we do in all of our swabbing programs, we don't because of the way our frequency of inspection works and when the inspector might be there and how much time they might have, it's not always feasible, but we try to take our swabs mid-operation. So they've been producing or making, say, deli meat for, you know, a couple hours. We'll have them stop momentarily and we'll swab the equipment, food on it and everything, swab the equipment, trying to find it while it's there, because those are the conditions where you would get contamination if it was going to happen. You're not getting contamination typically when everything's all clean at the end of the day and the food's all away. So we're trying to mimic the conditions of when we think the contaminations might occur. Anything we learn in the RSA obviously has to fed right back into the program, try and make constant improvements, get better and better. I do think a lot of positives that we find are probably in really, really good plants with really, really good operators, with really, really good food safety controls. And just for whatever reason, one day, one little chink in that chain was slightly weaker and something broke. And it takes kind of continual on top of it. I have had operators ask me or kind of suggest to me that, hey, we got negatives now, I got my program in, we're kind of good to go, kind of from the perspective of, well, we can relax a bit now. And my constant response is, that is the worst thing you can do. You can never relax, even if you're negative. This needs to be ingrained in the food safety culture. And to that effect, when we have these adverse follow-up meetings, as I mentioned, or maybe I didn't mention, my first question is, how much does a plant care? And I can talk a little bit about that a little bit later. Just got to stay on time here. Okay, I want to talk a little bit about the baseline that we did 2016, 2018, and kind of how it led us down this path and what we kind of learned about Listeria in our plants. And it was really informative regarding kind of a whole bunch of things in our facilities that led us to understand that we did have some Listeria risks that we needed to get in front of. So the goal really was to collect data on the presence of Listeria species, against species not monocytogenes, on both FSCS and NFCS plants that produce our tea product. We want to use that data to first assess whether we should have an EMP. You already know the answer to that. The answer is yes. And then really, how could we assist the inspection program and, more importantly, the operators to being more proactive in determining the risk and ensuring they don't contaminate product. The inspectors did collect all the swabs. And so there was a bunch of training and expertise in just doing that. And so that was super helpful. In total, we swabbed 83 different plants over about a 6-month period. We collected just short of 1,700 swabs, 10 per visit. We had aimed at the beginning to divide those evenly between food contact and non-food contact services. So if you remember that breakdown before, we were definitely putting more in the food contact area. And less in the kind of zone 3. That's going to shift a little bit when I show you the further results, only because there was a percentage of those that were really dedicated to retest, meaning we get a positive, we're going to go back, we're going to use more of those swabs and find out. And so that there is, for anyone who knows, that's Dr. Bolter-Bitzer. She was instrumental in kind of developing both this baseline and our monitoring program that we've instituted. She'd probably be giving this talk if she weren't currently on a leave of absence, but she is a plethora of knowledge in this department. So here overall, at a very, very high level, this was the results of our baseline. 58.5% didn't have any positives ever. So that's good news for them. Hopefully they're staying top of it. And we had just over 40%, which is more than we'd like, with at least one Listeria species positive. However, if you kind of look at these, and some of these numbers are a little bit confusing, so I want to make sure I set it straight here. The first visit, we had kind of 30%. Everyone got visited at least twice. So in the first visit, we had a 30% positivity rate. And then on the second visit, we had a 22 positivity rate, which means that, with pretty big difference, we did have an effect either in terms of the follow-up, we actually cleaned and corrected the problem and eliminated the Listeria that caused it, or also, and probably even more importantly, we did have an educational kind of deterrent purpose to kind of reduce contamination, build awareness, allow them to understand what's happening so they could better control it. And I feel strongly that the EMP program we have now across all of our programs does exactly that and helps to stay on top of it. Now, when we take the plants that did have a positive result, right, and so they did have an issue, and we went back and swabbed again, 56% of those had a positive again. So that means about all the people that have positive, just over half of them had a second positive. Now, when we followed up on those second positives, 3/4 of those had a third positive. So really, it told us that the plants that were struggling to eradicate it, they really struggled. So we didn't, you want to see that curve kind of go in the opposite direction. But for instances where we found issues, you definitely were able to identify that plants that had issues did struggle to reduce and eliminate those issues. And I think this is really a product that tells you about, how food and people move through a plant and how Listeria is happy to hitch a ride wherever it goes and stop along the way and then hitch a ride again. And so it really, after we did this and found this data, it really suggested some focus on some of these areas. Here's a breakdown of kind of the baseline by zones. And so I know that we had kind of taken, I had said we had designed half and half between zone 1 and the other zones, but here, when we add in the retests and everything we do, we can see the actual positivity rate. So we had 55% of samples taken in zone 1, but really our positivity rate overall was only about 5% there, where we're up around 8% in the kind of 39% of the zones of the samples taken in zone 2. So that kind of falls through. At first, it might seem a little bit counterintuitive, but I do think it makes sense because we do get a lot better focus on sanitation cleaning generally in those zone 1 surfaces. Everyone knows they touch the food. Everyone knows they have to be clean. We expect and do see from the data that you have less focus on those zone 2s and 3s, the ancillary parts that are just nearby but not quite touching and are really subject to some indirect contamination. So really at the end of this, it kind of told us that, and Janine and I really were kind of looking for, we had felt strongly that we needed an EMP and we were really collecting data to kind of support it. It did exactly that. We have rolled out EMP program across all our plants, but we did another really important thing too. And that is that previously we had a testing program in our finished product. If we had our finished product L mono positive, we would basically retest finished product again after they've done all their mitigation and corrective actions. And quite often we would see that the retested product was always negative. And then shortly after that, they might have a positive again. And we're like, okay, what's going on here? Like they're doing something special in the kind of follow-up, but then that whatever special thing is kind of falling off after the fact. And so what is causing that and how can we fix it? And really, we don't really know for sure. I'm sure there's a mixture of things. Sometimes it's just bad luck. Sometimes it's that, people are doing a really focused effort to cook that meat more or, extend the hurdles or really put the production of the stuff that would be a retest in a bubble to ensure it was negative. So then it doesn't really become representative of what we want to test and the conditions on which the rest of the product might be produced. So we moved to an actual swabbing program as a response to our finished product positives. Since we've done that, we don't get the same number of positives or them getting another positive again months after the fact. In fact, we've halved our Listeria positivity rate in finished product since we made that change. So it's been pretty successful and really demonstrates the power of EMPs. So like I said before, we have them in all our plants now. Now, to kind of just give you an idea here, here's a rough diagram. It's not exactly the scale or anything we're wanted to demonstrate of when we went out in the baseline. And I have said before, and it is very true, we don't want to really be testing for Listeria species in raw areas. Now, for the purposes of this baseline, we were really kind of wanted to test everywhere to kind of as a true baseline, get lots of information and really try to see if we can draw connections between raw areas and cooked areas and see some of that movement. I would never suggest you do that. Normally, this was a bit of an atypical situation. But here you can see if the words are in green, that means they tested negative. So in the swabs we took in that area, we tested negative. So this is the same plant, and words that were red. So this was the plant, so that you can see there was a number 10 or 12 swabs there, and they had a whole bunch that were red, So we told them, look, you got a whole bunch of red, especially in this lower RT prep room. The thing is filled with Listeria. Go and do good things. You got to fix it. You got to do a root cause analysis. You got to do some elevated sanitation. So they did all those things. We come back sometime after that, a couple days, week, whatever it is, and we swab again. And now here, they came back to us, so like, well, that cutting board, the cutting board was really grooved, very common. There's a lot of equipment and tools that you need to really, they have a set life, and at that life, you need to replace them because they become uncleanable. That's what happened here. And again, those plastic curtains that a lot of people use for separating areas and temperature control, they're notoriously bad, notoriously difficult to clean. They removed those as well. And they cleaned up the tables, and the vac pack machine was now green. But we still had some areas around this conveyor belt, slicer, and table. So go back again, root cause again. What else can we do? What's the problem? Really, really deep clean those areas more than before. Go back a third time. Now the table and the slicer, negative. We're in the green there. But this conveyor belt, again, positive. And they had Verge nuked this conveyor belt, and it was ultimately replaced. They had to replace it. They basically said we've realized now that we cannot clean this and have it negative, and it wouldn't have been throughout this EMP program that we're going to be able to get there. So it just kind of shows you, and I've seen slicers, thousands of dollars slicers be, all right, that's not cleanable. Can't clean it. So sanitary design, again, really important. So just to kind of close here, just to kind of go over the top, maybe 3 things, strategies for managing Listeria. Obviously, sanitation, first and foremost. Sanitation, we see more issues with sanitation than probably any other thing, but that's also because you do it a lot and it's super, super important. And relatively speaking, hard to do. Seems easy to clean stuff, but some stuff is hard, especially when you incorporate biofilms and cleaning niches, especially if you get really old plants that don't have proper design. Really important for battling Listeria that you want to keep things as dry as possible. If you have a cold, wet environment, that is party time for Listeria. And so I really urge people that are struggling it, like we've seen, I'll have inspectors send pictures, and if the place just looks dripping in sanitizer or dripping wet on a normal time, that's a problem. If possible, we tell people that after you clean, you should try and let the equipment dry and then apply a sanitizer so that you're not diluting the sanitizer with the water that's on there. And if possible, you want to dry out as much as possible. If you can't have water go in the drain, you should be squeegeeing it to the drain. Dry is good. Proper handling of RT products, right? You really want to limit contact between product surfaces and hands before it's packaged. So if you don't have to touch food, don't. If you don't have anything near the food, don't. You want to make sure you're using clean gloves, smocks, aprons, all the PPE you wear. You want to be able to make sure knives are cleanable and are cleaned. Sanitize them. You want to make sure people really understand this, and training new employees. In my experience, a lot of times it's people that have been trained and have let go and become complacent. That is also a very big risk. Plant design and maintenance, I've touched on a lot about this. Ready to eat work areas and coolers and the control and design of those is really important. Really want to eliminate traffic flow between raw to ready to eat. and back and forth. That is a big no-no. We have tracked actual positive issues to that exact root cause. And so that's a big no-no for us. Really want to store raw and RT products in completely different areas. If you're forced to, out of just sheer necessity, to store them in the same area, then there has to be really strong separation that is monitored on an ongoing basis in those areas. You want floors that slope to drain, and if you can't slope in the drain, you want to be squeegeeing water, and you really want to avoid maintenance activities impair when work hours are underway. If you do all those things, you'll stand a much better chance of battling Listeria and not having Listeria contaminated product. There are some brief resources on, well, some of them aren't so brief, to be honest, but where we got some of this information and where you can read Health Canada's policy on Listeria, as well as some guidance on EMP programs, and some of that stuff I had quoted from CDC. Over to you, Janine.
Okay. Thank you so much, Troy. We will now have actually 15 minutes for the Q&A segment of this rounds to address some of the questions from the audience. Please do continue. I already see quite a number of questions, but please continue to enter your questions into the Q&A pod if you haven't already had an opportunity. But just really wanted to thank Troy for a great presentation. And I know that we have, and I've heard through the grapevine, that we really have quite a variety of folks on the line joining us today from a variety of different settings. Of course, one of our main focuses is to provide resources for public health units. And while the plants that Troy spoke to kind of are a certain class and maybe a bit different from some of the settings that some members of the audience may be familiar with. I really am appreciative of how you've demonstrated kind of this issue of Listeria as a persistent kind of a problem for food establishments to manage, and particularly for those ready-to-eat product making facilities, and the importance of these zones and where Listeria can be found, as well as really pointing the way to kind of the extreme importance of sanitation and the vigilance that's needed to control Listeria. So really want to thank you for that. And as I now turn to the Q&A pod, and before I do that, I know that Troy mentioned, I think, GMPs in the presentation, and I think that was good manufacturing practices. Is that right,
yes,
Troy?
Yes, good manufacturing practices. Yes.
Okay. And just for our audience, again, just wondering if you're able to just provide a very brief kind of description of the kind of plants that you were describing, what you would typically see, as just to set a bit of a context for our audience.
So we have, in the baseline study we did, it was all in freestanding meat plants. So we define a freestanding meat plant as basically, there's a couple criteria. One, you're not killing animals, right? So there's no live animals in the facility. And number two, you're making a high risk product that's usually something that's, fermented, cured, canned, acidified, or you're making enough of a raw product, such a big volume that you have added risk. And so we inspect those facilities. Now, they tend to be smaller. They're not all, some are rather large, but they tend to be smaller than our CFI federally registered cousins. And they generally tend to be a little bit more niche, and generally tend to be a little bit more, sometimes we use the mom and pop sort of description. Again, I wouldn't say all, there's a vast mixture, which generates part of the problem. Additionally, we have the same type of thing in dairy, milk, ice cream, soft and hard cheese operations, as well as in foods of plant origin, where our regulatory authority is significantly less. But those would be things like, spinach, salad in the bag. We don't have a ton of those, but we do swabbing in those areas. And then in our fish plants, which follows a similar kind of risk profile that I explained about the FSMP. So it's, basically cooked, canned, cured, fermented fish, smoked fish, and or modified atmosphere packaging or vacuum packed fish would be the operations.
Thank you so much. Okay, and just turning our attention to some of the questions. There's one just about kind of the pushback that I think you mentioned. Was there a lot of pushback from internal food quality or inspectors, I think, at the facilities, at meat processing plants when the EMPs were implemented? And what was the challenging part to be able to get them on board? You can explain it.
Yeah, sure. So, there's definitely some pushback, and I think a lot of the pushback is associated with added burden. Oh, wait, you're going to test something new now, and you're going to make me do something new. And really, if I get a bad result, I'm going to have to do a bunch more stuff. And if I get a good result, I'm doing the same stuff I was doing anyway. So I think a lot of them kind of viewed it as this, how do I really benefit from it? A lot of our facilities don't really have what I would classify as true blue internal quality staff. Most of them, you're having the number of staff that work there, you're counting on one or two hands. And so there was a big education gap. So we did have to train a lot of, and we held webinars. And I really tried to focus them on some of the situations that poor Listeria management have led to, what those risks would represent. And let's be honest, if the worst case scenarios happen to some of these, I mean, they're business enders, right? Like if people are getting sicker, I mean, you're done. And the cost of ensuring that versus the cost of an EMP are vastly, vastly different. And so I really tried to kind of position it as, look, you want to know this. Taking a head in the sand approach to this sort of risk is not going to behoove you, and you're going to be surprised. So I think that when we kind of told them, like, look, as a ministry, if you get a positive, it's not going to mean a lot of bad stuff. In fact, you should view it as good information to use and fix. And once we did that, I did get a lot of positive feedback saying, thank you so much. It makes me feel so much better. There's no replacement for food safety culture. And, when we have these follow-up meetings, I'm always asking, how much do they care? If an operator on a result, if I say, how do they feel about it? And if the inspector says, oh, they're stressed out and they're worried and they don't know what to do and they're looking at chemical suppliers and they're stopping production to bring in, that's good news for me. Whereas other ones, I say, well, he wants to know how quickly he can get back into operation. I've heard that too. That's a red flag for us. It tells me that they're probably not caring, and therefore I do have more concern about their follow-up. So those are the ones that we end up to focus on as a regulator.
Great, thank you. And just to let you know, there's lots of questions. So let's
go. I'll go fast. I'll go fast.
We'll try to get through as many as we can.
Yep. Yep.
There's a question about explaining why not to do swabs in raw processing areas. Because they found mostly positives in raw areas.
So and I'm not surprised. And the reason we don't swab in raw areas because we would expect to find it. So it's just like if we take and test raw chicken, we would expect to find salmonella. It's generally expected we're going to find it. And when it is so ubiquitous and so in the environment everywhere, and you're bringing in those raw materials that have been untreated and have had no Listeria mitigation, we would expect to find it. And that's what's happening.
Thank you. Can you speak to the use of a pressure washer to spray the floors in these production facilities? Yes.
Yeah. So pressure washers, like, they're good and they're bad. So they're really good because pressure, obviously, there's kind of four things. I could do a whole session sanitation and I'm not going to get into it, but mechanical action is really important and one of the key factors of cleaning. And you either do that by, foam running down the surface or literally wiping and scrubbing something, or high pressure water can be really effective at jarring dirt loose and breaking up biofilms so that you can clean it. The problem is that you also aerosolize a lot of water and a lot of spray. And so that if you don't have control over your high pressure and don't have control and don't also have a really good cleaning system and protocol for the order of how you clean things, you're just going to end up spitting that aerosolized with potential Listeria all over all these other services, especially zone 2 and zone 3 services. So if you're going to do that, you got to follow that up with, well, I got to make sure I clean all these other surfaces too, or do it in such a way that you can control that spray.
Perfect. There's a group of questions. There's a lot of fascination with the finding about your doors, the doorknobs.
Mm-hmm.
So really
We are surprised
interesting.
too.
What kind of?
We're surprised too.
Yeah, good. Yeah, I think there's a lot of questions about maybe what kind of doors were positive. Were they more refrigerator doors, sliding doors?
Yeah, I'm not,
Yeah.
and unfortunately, I can't. I don't have the data to be able to fraction it down more for you. Most of our doors, I mean, they're not going to have the traditional knob. You might have a pull. A lot of them are just, steel plate in the side, push open and close. Didn't really matter. We would always test the door handle if it was there, because we know it would get a lot more touching, but we'd also test all surfaces of the door. And it just kind of told us that, generally speaking, people don't clean doors well. They don't clean doors well. It's not part of their sanitation program.
Right. Yeah. Again, putting attention to the importance of sanitation outside of just the food contact areas. Okay, so a question about Listeria being so resistant to temperature treatment and cleaning products, or at least maybe cold temperature, especially with biofilms. What is the most common type of cleaner facilities use that isn't effective?
That isn't effective. Oh, I don't know if I know
or
the answer
if you
to that.
have any, that are more or less effective for Listeria.
So my advice to anyone here is, a lot of times we get similar questions of the operators, and really we try to match them up with actually a sanitation or a chemical cleaning company. They're experts in this field, and really, really good programs probably actually even you could go through you go through cycles. You'll change chemicals because as things get resistant, you change it up so they become less, so I'm not sure there's a chemical I'll say that is I certainly don't know which one is the least at controlling Listeria. I'm not sure I've ever been asked that question. That's interesting. Most cleaners that have your basic soap elements are going to work, and there's just different levels of that. In terms of sanitizers, there's a lot of really, really good sanitizers. Kind of depends on your use and your application. Chlorinated sanitizers, super, super effective, but don't have a lot of latency. They don't last long. They'll kind of evaporate and then be less useful. Whereas something like quaternary ammonia would be better at lasting longer, but maybe not quite as effective at the beginning. We use, peracetic acid in a lot of our applications. Super effective sanitizer, but also, a bit dangerous and, has a bit of an odor to it some people don't like. So again, I would urge go to your local. I urge companies to go to their local sanitation company and get some pointers. Obviously, price is always going to be a factor, and how easy it is to apply. There are not many times, but there's been a few times where operators have wanted to use really effective sanitizer cleaning, and we've kind of told them, well, no, we don't think you should do that, just because I think you're creating a health and safety risk for your operators. So that also has to be part of it. The last thing I would say about that is you cannot sanitize a dirty surface, right? So I've seen some people who want a short sanitation by doing a quick hose off and then spray some sanitizer on it. You're wasting sanitizer, in my view. If you're not going to do a full sanitation and have a clean surface, that's when you use sanitizer and no other time. Yeah. There, people, even, when you put sanitizer hands, yeah, sure, it helps. It's better if you sanitize clean hands.
Yeah. Okay, question I think that might be of interest to a number of participants. Are there any specific challenges with small scale or artisanal food production facilities based on your experience, and what resources or support are available to assist these businesses in implementing effective control measures?
There's no doubt that we've had issues with certain pathogens with seasonality, especially Aztec in beef and veal in the summer. I'm not sure I've seen any data that would really suggest seasonality for Listeria. I think it's pretty used to going all year round. And in terms of size, I've seen really, really small plants that are relatively nuanced, have really good controls on Listeria, and really big plants that also, there's no, I don't have anything that can point to, yeah, this is the difference. I think the biggest difference in all those instances is almost, not always, but very much one of two things. One, it's again that food safety culture thing, right? Like if people don't think it's a big deal, yeah, I've never made any sick, or I don't get sick, or this food safety is not a real thing because they haven't had experience with it. That's a problem. That's the biggest one. And the second one would be some of the you can have all the best sanitation and GMPs in the world, but if you're cleaning something that you literally just cannot clean, then it's just not. So if you have old or aged equipment, that sometimes can be a problem.
Thank you, Troy. And I know that there are more questions, and I wish we got to more, but unfortunately it is 12:59, and we have to wrap up
Yeah, no worries. I'm sorry
close
I
the
went
session.
on too long.
No, not at all, Troy. I think you've in your explanation and discussion really answered and spoke to some of the questions that we weren't able to specifically get to. So thank you very much. And as a final note, as we wrap up, I just want to thank you again for presenting. I'd also like to thank everyone who joined us for today's webinar and the wonderful questions that were sent in. You can expect to receive a brief and anonymous PHO survey or PHO round survey for today's session. Please do try to complete this because it's extremely helpful for us to improve our programming. And as also a reminder, topic, the Ontario Public Health Convention registration is open and will be held March 26th and April 3rd. So check out topic, tophc.ca for details. And finally, to access past PHO presentations and to view this and the upcoming sessions, please visit the PHO website, head to Education and Events, and click on Presentations. So with that, thank you very much, Troy, and to members of the audience, and have a wonderful day.
Thank you. Thank you, everyone.